4th years you've just done this mathematics test. Most of you have done pretty well, but just in case there's some things you want to go through and check how you do them, here's a work through of the test. Now, you all got the first results here for the lower bound and the upper bound of A to 1 decimal place, which is 9.55 and 9.65. And then again for B, 8.15 and 8.25. Some of you did make an error here, and what we need to do is consider the upper bound and lower bound for A plus B. So adding the two lower bounds, these two figures here, giving 17.7, gives us the lower bound. The upper bound can be found by adding these two to give us 17.9. And this is where it really went wrong for some of you. The lower bound is going to be where we consider the lowest value of A, take away the highest value of B that's possible. So the lowest value of A is 9.55 and the highest value of B is 8.25. Subtracting those gives us 1.3. For the upper bound, we're going to want the highest value of A take away the lowest value of B. So that's 9.65 minus 8.15, giving us 1.5. Question 2, this was a Pythagoras question. And we can see here that we've got to calculate a shorter side. So 18.5 squared, which is the longest side, must be equal to 13.7 squared plus the value we want, L squared. If we rearrange that a little bit, we can say that L squared must be 18.5 squared minus 13.7 squared. Now if you put that in on your calculator, you can see L squared is 154.56. Taking the square root of that, and rounding to 3 significant figures, we get 12.4. Okay. Question 3. One significant figure, so only one non-zero digit there, gives us 30, and here 0.6. Again, most of you got this one, which gives us a calculation of 30 times 0.6, which is 18. Now, this next question, you need to work out the population given that it rose by 6%. Well, there's the population now. An increase of 6% is simply a multiplier of 1.06. And again, if we calculate that, that's 70,384. I think this last one on this page, number 5, considering two triangles A and B, if they're similar, they will contain all 3 angles the same size. Well, A, we're told, contains a 40 and a 60. So the remaining angle must be an 80. Triangle B contains a 40 and an 80, so adding these two is 120. The remaining angle must be a 60. So in fact, these have the same angles, they are similar. Going on to question 6. I think pretty much everybody got this one. You spotted that in fact the small one gets doubled to become the big one. So 3.5 gives you x is 7 centimeters, and obviously then the other way, we need to halve for y to see 3 centimetres. Question 7. Bit of rearranging here. And we're making x the subject, so just subtracting y from both sides. P minus y. Here, it would be useful to have 3x on its own by adding 2t. So it's q plus 2t. And then we can see that with 3x, we only want 1x, so we're going to divide by 3. So x will be q plus 2t all over 3. This was the one that got you. You've got x appearing twice, and you want it as the subject. That means you're going to have to factorise. So x times 2 and x times minus a equals r. This is an equivalent expression, but now we can divide by 2 minus a. So x is r from here, divided by 2 minus a. Number 8, this one got you as well, because it's a reverse percentage. So if we say that the original price times, well, 10% off means we're looking at 90% or 0.9. So the original price times 0.9, that's the 10% off, equals the 243. Once you've written that, you can see that to find the original price, we need a calculation 243 divided by 0.9, which comes out at 270. Moving on, this was a quick one. It's a cyclic quadrilateral. Opposite angles must sum to 180, so 60 and 120 give us that. The reason you must mention cyclic quadrilateral and that means opposite angles sum to 180. Similar one here, but different rule. You can see that you're going from here and here up to the same point in the same segment. So B is 20 because angles in the same segment are equal. This was a tricky one as well. A lot of you found AC, which is all this length, but then didn't go for just this length here. So we consider we've got two triangles here that are similar because of these parallel lines. We've got a small one, 2 meters, 1.5 meters. Then we've got a big one, 8 meters. And AC, which we don't know. Now you may have done this by ratios again. Looking at this, there's a multiplier of 4. A lot of you got that. So you multiplied this by 4. 1.5 multiplied by 4 equals 6. So the length AC is equal to 6. Which means that T, just the length BC, must be 6 minus 1.5, giving 4.5 meters. Last page. Now, this one again caused a few problems. If you see a square root like this, then the way forward is to square both sides, giving a squared on this side and completely getting rid of that square root sign on the other. Now we can start to isolate x. If we add b squared to both sides, x is nearly on its own, but we've got x squared. We simply want now to take the square root. But you can't square these individually, you need to square the whole thing. So if we square root this side and square root this side, we get a result. Don't forget your plus or minus for taking the square root. A squared plus b squared, or b squared plus a squared. Last question. So the reasons are not required here, but I will give them anyway. So A, we're looking at, well, here and here and here. This is all a radius. So we can tell that this angle and this angle are the same. And given that this one's 60, we've only got 120 left in the triangle to split equally between these two, giving us A as 60. For B, we might well look at these parallel lines and consider this transversal. This and this are alternate sides of the same transversal. Therefore, by alternate angles, which are equal, we can say B is 60 as well. C we can do by observation because this is a diameter, and this is then a semicircle. Diameter, semicircle, any angle there is going to be a right angle. Leaving just D. Well, if we know this is 90 and this is 60 from previous work, then in this triangle we can find that this is 30.